be able to do it now. There you go.
There we go. Perfect. So Paul, once again, it's a great honor to have just a moment of your time to have this
my pleasure.
much needed conversation. So let's just dive right in, if you would.
Yeah,
so that
sure.
we can make the most of the time that we have together. Just give us a little bit of a background on, I know personally that you are a primate research scientist. Is that accurate?
Well, my background is infectious disease in people.
Okay.
I didn't set. I'm a MD. I went to med school and did an internal medicine residency, then did an infectious disease fellowship.
Okay.
And that was, let's see, graduated from med school in '84. So I was, on the wards in New Haven from like '84 to '88.
Okay.
And that was when AIDS was really just starting to take off. And before we had any antiretroviral therapy. So, it was a tough time.
Okay.
And so I wanted to keep taking care of people, but I also wanted to do research. So I started doing AIDS research with an immunologist, physician, immunologist, infectious disease specialist at Mass General, and was learning about helping to identify particular part of the immune response called killer T cells that go out and recognize virus-infected cells and characterizing these in HIV-infected people. And then, as I got a faculty position and started up my lab, and then there was an opportunity to start looking in monkeys who were infected with the AIDS virus and trying to see, there was a situation where you could use what's called a live attenuated vaccine, so a weakened virus, and the monkeys had very strong protection, but the weakened virus is not something you'd want to use in people because of safety concerns.
Okay.
So this was something that was something that you would. It was a test situation that something you could do in monkeys you couldn't do in people. And so I spent much of my career studying those sorts of immune responses.
Okay.
So, and as time went on, I spent more and more time studying monkeys and immune responses in monkeys. But my background is as an infectious disease person. I haven't taken care of patients for about 8 years now. It's just I've been too busy, which I miss it, but I'm not an active clinician right now.
Right.
But that's my background.
Okay, perfect. So that gives me both perspectives that I was hoping to be able to kind of garner and gain more information and insight from. So let's talk about, there's some phraseologies that are being kind of bantered about that, like follow the science and and in general, just gravitating towards someone who is an expert. So with your background and your credentials, what are the things that we as the general public need to look for in an expert that we can trust with the information that they're giving us? Because one of my main concerns is that we're not hearing both sides of the conversation. I'm a holistic integrative practitioner, so my perspective and my paradigm is somewhat different from an allopathic practitioner.
Yeah.
Because I look at the whole body, I look at the whole experience, and then determine how things are impacted, or we are impacted by the external and internal things that can influence health, both physically and mentally and all around. So give us a little bit of maybe 5-point checklist of what we need to look for when we're seeking out information, seeking and comparing information. So how do I know that someone is a conspiracy theorist versus somebody who has valid information that they're sharing though sometimes the conspiracy theorists, if you listen to what they're saying, some of it makes sense to some people.
Yeah.
So
Yeah.
what is your recommendation of, okay, these are the absolute musts that you should take into consideration when you're looking for someone with a trusted voice?
Yeah. So it's a great question. And I can't give you a 5-part answer that it's going to winnow it down to the best,
Right.
most possible person. So that's one thing. It's a great question.
Too complex.
But it's hard to
Too
do.
complex.
And then the other is just to be very open. I think you know this, but about my, I'm going to say bias, that may be pejorative, but perspective. It's from an academic, I'm from an academic infectious disease perspective. And so I'm going to bring that to the table.
Okay.
So
go ahead.
So, I think, a lot of things I would say is recognize that it's also important to recognize that this is a new virus that we're still learning about. And so things may change. Good faith recommendations may change over time. And that's based on science and new information and people reevaluating things. And sort of a classic example is the initial recommendation from the CDC not to wear masks in public. And then as it was very clear this was respiratory virus, we had enough stocks, they realized that was really not a good idea and we want to flip to masks. And I think from my perspective, that is the way science works. Science isn't perfect at the start. Science is a process of eventually arriving at our best approximation of truth.
Okay, I'm glad you brought up two significant topics that I really wanted to kind of dive into. So the scientific community is still recognizing that the COVID-19 is a novel virus and that they're still learning about the virus as we go.
Yeah, and we know a lot now. We know a lot more than we did, but some people go back to, say, advice given in March and then say, oh, the CDC didn't know what they were talking about. I'm not going to listen to the CDC.
Right.
And again, that's my perspective. I think that's a big mistake. But science isn't perfect, but it's a process of arriving at the truth.
Right. So understanding that it's a novel virus, one of the things that I find challenging personally is that because it is a novel virus, there's some experts who are speaking from an absolutist kind of perspective. And so it makes it very difficult to not follow up with, well, the information keeps changing, so how do we trust the information? Because they're coming from that perspective of, I have the answers, I have all of the answers, even though we're still learning about it. So is there a need for an adjustment in that tone that gives us a little bit more sense of?
I think, yeah. I think scientists and public health people always need to be humble.
Absolutely.
Because to be careful about things we don't know. On the other hand, it's really difficult to convey a message to the general public about a scientific, like 6 feet. What's magical about 6 feet? Well, the curve sort of goes down like this. It doesn't go to 0 at 6 feet. It just gets lower and lower and lower and lower. So, but you have to tell people something. You have to say, you have to give people some guidelines and rules. And so, 6 feet, if you keep your distance at 6 feet, you will dramatically decrease the risk of infection. And we need to make that really clear. But we also need to say, doesn't eliminate the risk of infection.
Now, how valid
make it 0.
How valid is that the 6 feet recommendation, considering the fact that a sneeze or a cough, the trajectory of a sneeze or a cough is upwards of 30 feet? So if someone
Yeah,
is
no, and that's a
practicing
great point.
the suggested and the recommended protocols, how do we make it comfortable or palatable for the individual to understand that these are simply guidelines? They're not absolute.
Yeah.
I don't even want to say recommendations, but they're not absolute. So there's a wiggle room of using both the science that is at hand now, available to us now, as well as critical thinking. And I think that's where a lot of us miss it, is that we don't include our ability to think critically
Yeah.
from a very individual perspective a lot of times.
So, I mean, one is that that's why the recommendation is 6 feet plus a mask. Because I know the studies about the droplets, because there's both droplets and aerosols. And again, there was controversy about that. That's something that we've learned more about this virus. We thought it was mainly droplets, but it's good evidence it's aerosols which travel farther.
Right.
But the 6 feet applies mostly to droplets. And again, with a mask, it drops off a lot at 6 feet.
Right.
But it also depends on airflow. If you're in a room, at a church service,
let's say school, since that's a big thing right
Yeah.
now, where we're trying to get the schools back opened again, and many of them are not up to standard with their HVAC systems in general. So how do we, if we're going to push the return of schools, what is needed of the school systems to ensure that the ventilation and the circulation of the air is significant or qualifies for the children and the faculty and everyone else to be in the school building safely?
Yeah, and again, that's a great point. And it's not, again, it's 6 feet, it's mass, it's also, if you're indoors, and good ventilation. And I can't give you the technical details of what good ventilation means, how many air exchanges per hour, if that's 10, or I don't know that sort of engineering, but that plays into it too. And so you need engineering controls like plexiglass shields. You need to be 6 feet apart. You need to wear a mask. You need good ventilation. When you do all those things, again, this isn't my area. I haven't studied this in detail, but the data from the CDC suggests that the rate of infection in a school setting, particularly with 8th grade and younger, there's a difference between elementary school and high school, but with 8th grade and younger, the risk of transmission is pretty low.
Right.
And that's why they're saying that it's okay to open school.
I respect the fact that you said it's not your area of expertise. I appreciate that. So my question about that is then, why are we not hearing from individuals from OSHA and other environmental focused individuals who are expert in that particular area, so that we have a clear understanding of what we need to do in our homes, in our offices? I'm a massage therapist in an enclosed, a body worker in an enclosed room for an hour and a half, 2 hours with an individual. So how do I ensure, first and foremost, that I have met whatever standards that are in place, if there are any, and how to convey the fact that what I put into place as far as additional ventilation, because I don't have the option of opening the window in the office. So my only option is to increase ventilation through HEPA filters and things of that nature. But do we have a guideline that a resource that we can take a look at and say, okay, these are the bare minimums of what I need to do in whatever particular setting, in the schools and in my office particularly, or in our homes that are, built in the 1920s, that, don't necessarily have, up-to-date HVAC systems. So how do we determine what are the appropriate guidelines or actions that we need to be taking as individuals to ensure that we're doing what's best and most effective in minimizing and in mitigating the impact of transmission?
Again, I'm not an expert in this. I do highly recommend what the CDC has on their website. And I just checked, and they have a long section for workplaces and businesses, and they have a full section on ventilation in buildings that was last updated on February 9th. And I can email this to you.
Okay. Yeah, any information that you have, and once again, I'm just gathering information. I'm gathering things that I can further research and look. I'm that person. I'm the one who questions the question, and
Yeah.
I kind of have somewhat of a scientific mind, so I understand scientific processes a little better than the average person who doesn't have any kind of medical exposure.
Yeah, and I again, in terms of getting back to your original question of what sources do you trust, I again, with an admitted bias, I think the CDC has worked really hard to communicate clearly. I think they were clearly, their ability to communicate clearly based on science was inhibited significantly during the last administration.
Okay. So we're looking at the CDC.
Whatever you.
So the CDC is one of our gold standard resources for information.
I think it is now. It has not been quite at the level it should be for, and they're doing a little catch up. I actually know the new director of the CDC was in the infectious disease department at Mass General, where I was before I came down here.
I listened to her.
So I have great.
I found her on a recent.
I have great respect for her.
Yeah. So she was very transparent, and that's another thing that I find is necessary, is the transparency of it all. So this is where I want to go with the transparency note. You as a researcher, what are the absolutes that you have to have in place to begin a research project? Like, for instance, human placebo, and isn't there a third kind of or checkpoint that is necessary for research for, let's say, vaccines? So if you're researching a vaccine, what are the main thing, the absolute things that you have to have in place in order to verify that this information that you're creating or that you are researching is going to ultimately result in the objective that you have in mind?
Yeah, there are a whole bunch. And it depends on the funding source. So if it's the National Institutes of Health, the funding is, they have a variety of different requirements. And it includes, for human subjects research, it includes review by a special board called an Institutional Review Board, an IRB. Maybe that was what you were thinking of, but any research involving subjects needs to undergo review by an IRB, and that IRB has to include community members as well as scientists at the institution. It needs to be, people need to declare potential conflicts of interest, and when possible, eliminate conflicts of interest.
Have those been declared in the 2 and potentially 3 vaccines that have already come to market and are on the way to market? So the Pfizer, the Moderna, and the Johnson & Johnson, have they all had the human? They've all had the human testing.
Yes, and so
how about the animal testing? Have they all had animal testing?
Yes,
they have.
Yeah.
Okay.
It went in parallel instead of doing animal testing and then doing the human testing. The animal testing started a little bit before the human, like for the J&J, the animal testing. I know the guy who developed the J&J vaccine, again, a guy I know from Boston, Dan Baruch. They did animal testing from, February to April, but also were already gearing up for human studies, and they could build on the fact that there was also already a lot of work on this vaccine as a vaccine for HIV, and there's an efficacy trial using this Johnson & Johnson vaccine based on a cold virus that's ongoing now to see if it can prevent HIV infection using a different vaccine, but using that same sort of platform.
Okay. And so you said that they have done the human trials. So with the human trials, do you have any insight on what the inclusion and exclusion criteria were, as far as who qualified for the trials and who did not? And
the initial trials were one, the Pfizer vaccine was age 16 and up. The Moderna vaccine was age 18 and up. So they initially did not include kids. That's an important area we can come back to. They did, I think they excluded people who had immunocompromise. And so what that meant was I don't know the definition, but there was, I think, a recognition that they needed to include HIV infected people on antiretroviral therapy. And so they actually went back during the course and modified, and I need to double check, either the Moderna, I think they got pressure appropriately for Moderna or Pfizer, or maybe both, to include HIV infected people on antiretroviral therapy in the trial.
okay. So that's the age, and then some of the symptom or the pathological guidelines.
And they also worked hard to include older people, like 60, and actually the definition older was 50 and up.
Okay.
But they had a number of people, and it's particularly true of the Pfizer vaccine at Emory. They were very good at enrolling people who were 60, 70, and 80. And then they also made a bigger effort to enroll minorities, and that was an area that many trial sites weren't very good at. Emory is very good at it. They've built a nice relationship with the community, and so Emory has been one of the sites that's been very effective. And they actually went to Moderna and had them slow down, because when they looked at their initial numbers, they weren't recruiting enough minority subjects. And they said, look, we're not going to go forward with an approval unless you get a higher number of minorities. And Moderna had to change their timetable, and then had to really make an effort they saw which sites were better at enrolling in minorities and increase that. So there was better representation.
Now, with that being said, and there's been the differentiating factors in cultural differences in the testing, what were some of the findings that they found with the efficacy of Moderna or Pfizer, since they're the two primary that are actively being? What were some of the findings that were in favor of, possibly in favor of one group, but not necessarily ideal for another? Are there any inconsistencies that were found that one group of people should not take one vaccine versus another, or?
Not that I'm not aware of any so far. The Moderna and the Pfizer vaccines are very similar in that they include, do you know about DNA and RNA? So DNA, is our basic genetic code. And then the way we express it, the way we make proteins from DNA is RNA. And so RNA is it is the messenger molecule.
Okay.
And so both the Pfizer and Moderna vaccines are just the RNA. And RNA is something that doesn't last long in the body, but it lasts long enough to make the protein just a piece of the virus, and the key piece of the virus that you want to make antibodies to, so it blocks infection.
Okay. Now, what type of antibodies are we hoping to produce? Are we looking to produce the ones that are going to help with fighting the virus, or because there's different types of antibodies? Am I correct?
Right.
Okay. So
Yeah.
which one are we hoping it produces, and are they meeting that?
Yes, and the key is to produce a type of antibody called a neutralizing antibody.
Neutralizing and blinding. Okay.
And so if you see if you think of a virus as a key going into a lock, right? So the lock is the cell, the key is the virus. If you're an antibody, that means you stick to a part of the key, right? If you stick to the back of the key can still get in the lock. If you stick to the front of the key, it's blocked, and the key can't get in the lock, and you've prevented infection.
So this is what is understood when they're saying that it's not entering into the nucleus.
Into this. Actually, these just need to get into the cell. They don't need to get into the nucleus.
Right. So these are, but that's what we should understand. What you've just spelled out is essentially what they mean, because that's been the challenge. Is there's been talking points that the average person doesn't necessarily know how to define.
Yeah.
So you essentially define what is being intended by the people who are saying, well, it does not enter into the nucleus. So therefore, not entering into the nucleus is what is the expected result of it having not entered the nucleus? Immunity, or
yes,
minimized infection, reduced infection, or what's the main objective in that?
To eliminate infection. So, both the Pfizer and the Moderna vaccines prevented over 90% of symptomatic infections, and also prevented hospitalization and death. So over 90%.
So you said symptomatic infection. Does that mean that there's still a potential for infection and we don't know that we have it and can still transmit it?
That's a great question, and it's been something that we've looked at. There are some vaccines that prevent disease but don't prevent infection.
And this one is on what?
And it's a little harder. It takes more work in a study to look for infection, because you have to do virus swabs on a regular basis. But they've done that now, and there's just a paper that actually just came out in the New England Journal of Medicine in studying patients in Israel, or people in Israel who got this vaccine. And once you've had 2 doses, the ability to prevent infection or shedding is over 90%. It's 92%.
Okay, so just to be perfectly clear, so you can get the vaccine. There's still a possibility of becoming infected, and a possibility of being a vector of that particular infection.
It is, but it's reduced by over 90%.
Okay. So it's not an absolute guarantee that you're not going to. So the objective of these particular vaccines is not to provide absolute 100% no infection of any kind necessarily.
Well, that would be great. We would love to do that. It's very difficult to do that. These are some of the most effective vaccines that have been developed against any infectious disease.
Okay. So since we're using the term vaccine, because I wanted to make sure that we understand what exactly the definition of a vaccine is. So tell us exactly what your understanding of the word vaccine is, and how that particular definition includes the mRNA vaccines that we're now seeing.
So a vaccine is any drug, basically, that is able to induce an immune response that prevents an infectious disease.
Does it require the live version of the virus or attenuated version of the virus to be?
It depends. There are sort of three basic types. There's one where you take a weakened version of a virus. And so like measles is an example of that. They took the measles virus, they made it weaker by growing it in the lab. And when after 4 years, they gave it to people and they didn't get sick. They didn't get measles, but they were over 90% protected from getting measles.
Okay.
So that's called a live attenuated vaccine. And so that is a vaccine that replicates in you a little bit, but it doesn't give disease.
Okay. So how do the mRNA vaccines fit into the current definition of what a vaccine is? Or should they be called something else? Should they be called a technology? Should they be called gene therapy? Should they be called something aside from a vaccine? If they don't meet the qualifications or the definition of what is currently defining a vaccine.
Yeah, they're clearly a vaccine, and so they're just they're a new type of vaccine, and so it's almost similar to a live attenuated virus, except because the measles virus is an RNA virus, so it's like instead of getting the whole virus, the virus gets in your cell, gets in your body, and it makes RNA. So this RNA vaccine is like skipping that step. No virus, and we're just going to take and express the very part of the virus that's most important to make it antibodies to. So we've skipped that step. It's like sort of a surgical strike of a live attenuated virus.
Okay. What is a potential setback or challenge that could come from skipping that particular step, if any?
I think that the key is to make sure that they pick the right piece of the virus. And although I'm saying it's a new virus, we know the virus family it came out of, which are coronaviruses, type of cold viruses, and it included SARS, the original SARS that developed in China. And also, I don't know if you've heard about the virus that in camels, the Middle East Respiratory Syndrome virus. MERS. Yeah. And so those are also coronaviruses. So people had worked hard on making vaccines and figuring out the tricks to make pick the right part of the protein that would block infection. And so we had a lot to build on. That's why we were able to move so quickly, because they actually knew exactly what part of the virus to pick out, to put into RNA, and then to go forward with that. So they were already in prime.
Right.
That's how they were able to move so quickly.
So let's look at the term safe and effective. What exactly does that? What criteria has to be met in order for the FDA to determine something to be safe and effective? Number one, and number two, why authorization but not approval?
Yeah. Again, I need to be careful because I'm not an FDA expert, so I'm going to give fairly general responses. So, in terms of safe and effective, they had decided, based on a variety of criteria, that it had to be more than 50% effective in preventing symptomatic infection in order for it to move forward. And so that's what they did. This clearly, these two vaccines that are already approved, and actually J&J I think should be approved this afternoon, are far above that threshold of 50%. Safety is determined, again, safety from an academic perspective is a relative term. There are some vaccines that we give that have, a risk of side effects that are 1 in 100,000 or 1 in a million. We don't like even that level of side effects because you're giving this to healthy people. But depending on the disease, sometimes we go forward. But, you know, for instance, Merck, one of the big drug companies, Merck, made a vaccine against a virus that infects kids and causes diarrhea in kids. Really big worldwide problem called rotavirus. They spent, I think, between $700 and $900 million on this, on developing this vaccine. When they started testing it, it looked really good when they tested tens of thousands of people. When they started testing hundreds of thousands of people, they found that in kids, there was an incidence in about, I think, 1 to maybe 5 in 100,000. I'm not sure the exact percentage. A low frequency, but a real frequency of a thing where the vial folds up on itself, called intussusception. And it can be serious. It can require surgery. And particularly in resource poor settings, you don't want people having their bowel fold up each other. So they pulled the vaccine. They pulled the vaccine for an incidence of side effects that was around 1 in 100,000 kids.
So what side effects are deemed acceptable and others not acceptable?
Right. And so the other concept is that there's something called, have you heard of the term reactogenic? So, you know, they're reactogenic side effects, and your body, when it encounters an infection,
I've heard of reactogenic, but for the lay people, define that for us.
I'm going to try to define it. Let me work on trying to define it. Reactogenic is like fever and feeling bad.
Okay, so you're reacting to something
like sore arm, fever at 102, you feel crappy. That's reactogenic. Now, is that a side effect? Yeah, it's a side effect.
Response. It's a response.
It's actually a good side effect.
Yeah, we'll say response instead of side effect. How about that?
Yeah, and it's a way that basically your body has a way of kickstarting immune response, and that's reactogenicity.
Okay.
So we don't want everybody to have fever 102 and feel crappy, but that's not the side effect that we're worried about.
So medical terminology 101. So you take two words, generally medical terminology, there's multiple words that are combined into one.
That's what we do, yeah.
Genic means the genesis or the beginning, and the reaction is, so it's the beginning of a reaction.
Thank you for breaking that
down. How about that? Yes. Medical terminology 101.
Very good. So anyway, so so reactogenic side effects are something that means the body's immune response is kicked into gear and making an immune response. So that, you know, as long as it's within reason, that reactogenic side effects are something we pay attention to, but they're not considered in general worrisome. You know, other side effects would be.
Well, before you move on, so say for instance, someone has the initial soreness or a headache or upset stomach or, you know, what have you, that is the reactogenic process at play. At what point do we determine that, you know, 3, 4 days, 5 days later, they're still experiencing some kind of reactogenic? Yeah. Then how do you determine whether or not that's moving into the, I don't want to say anaphylaxis, because anaphylaxis is typically something that happens immediately.
Yeah, anaphylaxis. We'll come to anaphylaxis in a moment, but that's not anaphylaxis. Again, the side effects, they keep a close. They track. While I say they're not unexpected, they track things. They track. You know, when people have fever, when they have a sore arm, they track all these things. They are usually with the vaccination in a minority of subjects. Again, I don't know the exact percentages. I think 20 to 30%, you know, have fever or something that would cause them say, I'm not going to work today. So, you know, overall that's relatively low, but it's still a significant number of people. But it's generally 24 to 48 hours when it occurs. Okay. It doesn't usually go on for 3 to 5 days. I don't know that doesn't happen. It's just, it's not very common. The people who did experience those reactogenic side effects, usually 24, 48 hours gone.
Gotcha. Okay, so we spoke about the safety. Did we speak about what efficacy means? Did we clarify that?
Yeah, efficacy is most importantly, they're preventing symptomatic disease, people who have, people have a cough, people who have symptoms of COVID-19. And then they also looked at preventing hospitalization and preventing, serious disease, including death.
Okay.
And it was effective, at 90%, over 90%, really, for all of these, categories. And then again, the most recent data I just saw actually an hour ago, somebody emailed me from Israel. They studied over 500,000 people. So that sort of gets to the safety thing I just wanted to pick up on a little bit, and what you said, the EUA, why an EUA? And again, I'm not an expert in that, but I just wanted to highlight that because vaccines are given to healthy people, our bar for safety is really high. So we know that these vaccines are effective by studying them in 15,000 people, but we need to see that they've been studied in hundreds of thousands to millions of people before the FDA says, yeah, we'll give this a regular authorization. So it's that really 10 to 100-fold almost expansion in how many people are vaccinated.
So you made
it says then that's when they'll move on with authorization.
You made an important distinction there. So you said regular authorization. We're in a place of an emergency authorization.
Right.
So how is that different as far as, because when questions have been asked about any shortcuts that have taken place or whatever, how does the FDA or scientists or whoever, how do they determine what requirements don't necessarily need to be taken into consideration when they're considering emergency versus average?
Yeah, again, I don't know. One is the numbers of people, but
that could be impacted by the disease.
The number of people. So if to get back to that example of rotavirus that I talked about, if you're looking for a side effect that occurs in 1 in 100,000 people, you're actually going to have to study 500,000 to 1 million people to see it.
Have they done so in the MNR or the?
So right now, well, there's still, yeah. So right now, gosh, I think overall 13% of the U.S. has been vaccinated. So that's probably what, around 30 to 40 million in the U.S. So we're up in the tens of millions of people.
Okay. Now I wanted to go back to this topic of having been vaccinated and potentially still acquiring the infection. So say you've been vaccinated,
yeah,
and you still come down with COVID-19. Where are we with the studies on the impact of those who have received the vaccine, who are infected and now are classified as long haulers? What kind of research do we have currently that is giving us some kind of level of reassurance that if the vaccine is received and you are infected, what to potentially expect as far as whether you're not going whether you're going to end up with coagulopathy issues, or you're going to end up on dialysis, or the things that have typically been happening with long haulers that hadn't been previously vaccinated. So where are we with the vaccinated who become infected, and what are the long haul implications or potentials?
Yeah. So again, we do know that the vaccine is very effective in preventing not only infection, but also serious disease. That took bigger numbers because it's more rare. So I don't know right now of any reports. I'm not saying it doesn't exist, and say I'm not aware of any people with long haul symptoms who have been vaccinated. Based on the data we have, the vaccine should dramatically decrease the incidence. And one of the things they were looking for, it took a while to get enough people with serious disease, is to make sure that the vaccine, wouldn't worsen the course of infection in some way. Like you might get a decreased chance of getting infection, but if you got infected, you might do worse. That's not true. There's clear data that the vaccine not only prevents infection and symptomatic disease, but also prevents serious disease. And I just checked while we were talking. So there are 23 million people who have been fully vaccinated in the U.S. so far, and then a lot more people are there's 72 million doses given. So that's looks like, just doing the math, I'd have to check. It looks like there are probably another 20 to 30 million people who have only gotten one dose. But we're now up into the tens of millions, and so we're continuing to follow safety in that population, which gives us a lot more confidence that these are really good vaccines.
Okay. So we're at the place now where they're promoting mask wearing, which I'm a proponent per se. However, I also understand that different masks have different purposes. So if there's going to be a mask mandate, how do we know, or how
Yeah, hold on
Sure.
Andre, I'm sorry to interrupt. There's
No,
something, I told you there was something going on with the electrician, and I just need to run downstairs and see what's going on.
You're good. You're good.
So give me a second.
Perfect.
Sorry. I apologize for interrupting.
You're fine. You're fine.
Okay. Yep.
So thank you all for joining me on this quest for information, and it's as much for me as it is for you all. So I really wanted to make sure that we had a voice that was going to give us a good sound understanding, so that we can make informed decisions about this current situation with COVID-19 and where we are and how we should move forward. So this information is for you all as well as for me, so that we can be empowered to make the appropriate decisions that are, for us. Everybody's decision-making process is going to be different, and they're going to take into consideration different factors that are unique in some instances to them, and will have to be taken into consideration in addition to the information that we're being given today and have been given up until now. And because it is an ever-evolving situation, as we expressed earlier, we want to be as fluid with our acceptance of the information, so that when the information changes, we can also shift into that new understanding without being laden with the information that we've previously been given, if it doesn't seem to parallel with the information that we've previously been given. So let's make sure that we're open, we're receptive to information, vet your sources. It's always a good idea to get a second opinion about an opinion, and science is, in some instances, an opinion based on certain criteria that causes it to qualify. So let's remain open in the information that we're being given today, so that we can take this information and make the decisions that are going to help us to make the decision as to when to be vaccinated, if to be vaccinated, how to go about doing it. So now that Dr. Paul is back, we'll continue, but I was just kind of filling in the spot there for us.
Okay, yeah, no, sorry for the dead time. So
no, you're fine.
I'm gonna have to wrap up around 5-ish.
Understandable.
But anyway, so
next time I'll see if I can get some sponsors, and we can pay you.
I'm happy to do this. And Cheryl says hi, by the way.
Hey Cheryl, thank her for the connection. She's the one who brought us together. So
yeah.
So let's finish up with the mask situation, because now they're saying that double masking is recommended. So let's look at the implications of double masking and how that could potentially impact the respiratory exchange, and if there's any increased likelihood or potential for CO2 poisoning, if that's a thing that should be considered or a concern, and which masks should the population at large be donning, because we have face coverings that don't necessarily meet the requirements for a respirator mask or a mask that is intended to reduce
Yeah.
transmission or reduce exposure. So how do you recommend we go about selecting the appropriate masks, and is double masking the thing that we should be doing?
Yeah, so again, I need to be careful here because I haven't reviewed the most recent CDC recommendations on double masks. So I just need to be careful. In general terms, masks filter out material, filter out really small things like pieces of spit, basically, floating in the air that have viruses in them. CO2
Is this
is
all,
much.
is this all masks, or certain masks that
No, that's what masks do, but they do different. Some masks filter different sizes, and they filter with different efficacy.
right?
You can think of it sort of like a sieve and a net, okay? And
So with the particle size of the coronavirus, which is the most ideal mask that we should be donning?
so if you were able to get a the N95 masks, we're sort of reserving for medical use, but there are KN95 masks that come in from that are being supplied from China now. You do have to be careful about the KN95 masks and to see if they've been appropriately approved. So you do need to be careful. There are some counterfeit KN95 masks. They're masks that don't quite meet the criteria. So
that can be found on the CDC website. Let me give this insight here, because I've already researched it. So it's it's a CDC website, and it's the the National Personal Protective Technology Laboratory, which is going to give us the information on the N95, the respirators, and the things that they protect from and how they protect. So cdc.gov, the National Personal Protective Technology Laboratory, or NPPTL for short. I'm done.
Yes, that's exactly what I was going to say. So in terms of the sieves, having two masks together can be more effective, and for some people it can help fill in spaces. Some people, most masks work pretty well on my face, but my wife Cheryl has a smaller face, and so there's some KN95s that don't fit her face as well. So again, the best thing is to have a mask that fits your face, but if you don't, you could then have a cloth mask that fits your face better, and then have another mask over that to use the combination of trying to fill the gaps and get the filtration. But the important thing is to wear the mask. The other is the nose fit, and the nose fit is really important.
That's key, and I see that all the time. So regardless to the type of mask you have, make sure that you take a moment to press in that little metal wiring that's up there, and that doesn't belong on your chin, it belongs on your nose. Okay?
That's right.
So make sure the metal piece is pressed in against your nose so that it fits the form of your face and your cheeks.
And you can buy adhesive nose wires that you can stick on your face. If you have a favorite cloth mask, doesn't have a nose wire, you can get them, from a well-known online retailer.
Or if you need to hood rig it, just use a clothes hanger and just bend it or whatever. I'm just playing. I'm kidding. Pay me no attention.
Anyway, but the clothes hanger is not good because it actually is not as flexible enough to fit your nose.
I told him not to pay me no mind. It's okay. Perfect. Well, Dr. Paul, I appreciate your time. I really do.
I hope this is helpful. There are a lot of things to unpack here.
There are lots of things, yes.
But it is really important.
Yes.
Because we're still, things are heading in the right direction, but we are still at an unacceptable level of transmission. People are still getting hospitalized. They're still getting sick.
Okay.
And we need to get as close to zero as possible.
So appease my integrative practitioner just a little bit and give us some insights on what we can be doing nutritionally, what we need to be doing as far as ensuring we're managing our stress effectively and our mental health. So let's conclude on that note, if you would.
That's all key. I'm going to slip in one thing that's sort of at the interface of holistic, and that is, and it's a little less important now that it's getting warmer, but for people who are in colder climates, but that's humidity. Humidity dries out your lungs and makes you more susceptible to respiratory infections. And in the winter, you get the hot air and the humidity can drop down as low to 30, actually 20% or lower. That makes you more susceptible to viruses.
The low humidity or the higher humidity?
Lower humidity.
Lower
so
humidity.
You don't want it too high because then you get fungus. But the sort of sweet spot is 40 to 60%.
Okay.
So I think that's sort of somewhere in between, holistic and that, but humidity is a practical thing you can do.
Okay.
To keep your respiratory tract healthy. It's like your skin. If your hands get really dry and cracked, you're more susceptible to infection. Think of it just like that, your hands, but inside your lungs. So you want to, and then you want to sleep, stress, finding a way to relax even in these crazy times. That's all important to maintain your immune system. Absolutely. Eating a healthy diet, vegetables, fruits.
No sugar. Some people say less sugar. I say none. So
I'm working on that. I'm down to less sugar. I'm not no sugar.
But sugar creates inflammation in the body. We all know that.
A way to safely connect.
And mucus.
Yeah, I know. I'm not promoting what I'm doing. I'm just explaining what I do. And then finding a way to safely connect with people. To stay safe and stay sane.
And for me, safely means outside in a well-ventilated area. If you're coming to my house and you expect them to come in, you're not. So just don't tell you that right now. You can sit on the porch and we can chit chat all day long, but you're not.
And with the warmer weather, it's a lot easier to do that. But yes, you're right.
So it's not an absolute can't connect. Don't social distance. You want a physical distance, but not social distance. You want to be social. It's a human nature to be social and engage.
It's important.
It's necessary. It's absolutely necessary. So, Dr. Paul, you've got electricity things to deal with and all that fun stuff. So I'm gonna set you free. You are free to roam. How about that?
Okay. All right.
I greatly appreciate it. I would love to do this again, perhaps. I also have other practitioners that I collaborate. My office is actually in a psychotherapy collective. So I would love to have yourself and maybe holistic or one of the mental health practitioners that I work with, as well as I've worked with Dr. Susan Blank with Atlanta Healing Center. And I would love to have her take on how this situation has impacted the addiction aspect of what's been going on. So
yeah, no, that's a huge.
I would love to continue to dialogue about this so that we elevate the level of trust in the voices that are speaking, but then we also receive the information that we need to make an informed decision. So that's my main objective with this whole chat session. So I greatly appreciate it. Again, thanks Cheryl for making
Cheryl sends her regards
for making the connection. So until next time, I wish you Godspeed, stay safe. And
you too, André. Great to talk with you.
Likewise, pleasure.
Bye-bye.
Take care.